All right, exercise 5C. It is practicing your exponential laws. You've done this since pretty much the start of year 7. I mean, I do it again in year 8. We go up to probably that law. And then year 9, you pretty much do all 8 laws. And then year 10, you repeat that. Year 11, you repeat that again. So I just filled out the first 6 because I assume that you should know it by now. The only 2 that I think students tend to forget is index law number 7 and index law number 8. Let's see if you remember. Can I please have... Okay, Samar, let's go with index law number 7.
Is it 1 over 8?
Very good. 1 over 8 to the power of m is correct. So a to the power of negative m is the same thing as the reciprocal and positive power. And the last one, which a lot of people tend to forget, what is the nth root of a to the power of m, the same as in index form? Can I please have... Let's go with Jason. M over n is correct. Well done. So for those who didn't know, nth root is always the same thing as saying a to the power of m to the power of 1 on n. So nth root. So whether it's third root, fourth root, it would be 1 over 3, 1 over 4. And so then if you used rule number 4, or number 3, that's how you end up with a to the power of m on n. So number 7, number 8 are probably the 2 that students, especially in year 11, start needing to practice. But the rest, I assume that's where they're at. So in year 12, what's different? They will then chuck in example 1, as you can see. I've got 4 examples there, but I'm going to do 2 of them. I'm going to do the first one and this one. This last one here is the typical exam type question where they take an exponential and they try to convert it into a quadratic problem, or they could take a logarithmic and convert it into a quadratic problem. So those are your 2 typical types for exam 1. Okay. Why am I picking this one? Because there's something about fractions that students really struggle with in general. So this is the one I like to sort of start off with students. So I'm going to pause the video for a second here. I'm going to get you to try the first example using the 8 laws that you have in front of you. Simplify this expression shown, and ideally you have all positive index powers. Okay, I'm going to give you, let's make it 2 minutes. I'm going to pause the video. If you've got the correct answer, hands up if you got x squared times y squared. Unless I did it wrong. Did I do it wrong? I could have done it wrong. Let me just double check. The fact that no one got it right means I must have done it wrong. What did I do wrong? Did I do it wrong? Plussing y squared, x squared, denominators x squared, y squared, yes. And then the reciprocal, so... Yeah, and then those 2 cancel out, don't they? Wait, did I do something wrong? What did you guys do wrong? Do you see what I just did? So I just did that rule, index law number 7, fractions on the bottom, cross method. Here it is. And then just in case, I was going to skip the step, but just in case your fractions aren't strong, I decided to explain what I did. I just took numerator divided by denominator. Fractions, when you divide, you do reciprocal in times. But x squared plus y squared divided by y squared plus x squared is the same thing, so you can cross off the factors. And then your answer is just x squared, y squared. 1. So if you made a mistake there, it's probably somewhere to do with fractions. That's what I mean. So when you pick your questions, if you got this one wrong, practice fraction on fraction. It's expected at exam 1. Examiners like to do that because they know students tend to screw up somewhere with negative powers. So that's A, and then B, you guys can do it in your own time. I mean, it's the same thing, just go through the powers correctly. I'll write up the solutions later. But I'm interested in example 2B. This one you would have seen last year, and we probably chucked it in the exam as well. Let's see if you can see it. So this one should take possibly, again, another 2 minutes. Here we go. 3, 2, 1. I'm going to pause. Okay, 3, 2, 1. these type of problems is noticing that 3 to the x over here, or I'll just highlight it, 3 to the x, you can also rearrange this using index law number 3. Index law number 3, you could also rewrite it as 3 to the x all squared. So index law number 3, 2 times x, or x times 2 means the same thing. And why did I write it like that? It's because this is the same as this. Okay, so if I rewrite it again, that becomes minus 12, 3 to the x plus 27 equals 0. And hopefully, if it still doesn't help, you could also then say, let a, or whatever letter you want, equal to 3 to the x, and you end up with something like this. You end up with a squared minus 12 times a plus 27, and suddenly that feels a lot easier to do. Okay, so then quadratics, using quadratics, let's see if we can do cross method. What's that? Maybe 9 and 3. Negative 9, negative 3. Yep, that works out. So therefore, a is equal to 3, or a equals to 9. Since a is the same thing as 3 to the x, therefore x could equal to 1. Or this is 3 to the x equals 9, so then x equals 2. Usually in the exam, why it's 3 marks is because usually one of the solutions is undefined. One of them will end up being a negative, which is not possible to do, and then you're meant to state that. Okay, so you're meant to say, since 3 to the x can't be less than 0, therefore the answer is blah, blah, blah. That's how you get your 3 marks. But that type of question there, that is as typical as you can get for the exam. Okay, other than that, everything else is just revision of your 8 index laws. So again, you can whip through exercise 5C if your index laws or algebraic approach is good. If not, this is a good time to practice it. On the back of the sheet, here are some exam questions from the past. And like I said, these last two, 3 marks and 3 marks, that was 2011 and 2015. Very familiar, very similar to the one we just did. Okay, so have that under your belt. I'm pretty sure they don't do that anymore. But if they do, chuck it in. I reckon it's a trig function. Okay, so it'll be a trig function with the same idea where you have to solve for trig, but it's going to be quadratic involved. Okay. All right, team, that's pretty much for 5C, and that concludes this week's goals, which we've done all the way up to 5C. So even if I'm away on Friday, you should be all good. Now I've got about half hour to check through homework. Is your time to do your work. Ask each other questions.